Today we are going to start the topic as stationary waves. So already we have seen the progressive wave, and when that two progressive waves will get superimposed on each other. So due to superimposition, there will be either enhancement in the amplitude, which is to be called as your constructive interference, or there is a decrement in the amplitude, which is to be called as a destructive interference. Right? So that is nothing but your principle of superposition of waves. Now using that, now we are going to consider the concept which is to be called as your stationary wave. Now what this stationary wave is, here I have considered the two rigid support, and in between that two rigid support, a one string has been stretched tightly. So the string having certain length L is stretched between the two rigid supports. And if that string will be plucked at the center, so at the plucking point, so just consider that at the plucking point, when we are plucking with the help of finger, means you are giving the potential energy to that plucking point. And when that potential energy is given to that plucking point, so due to that potential energy will be received at this plucking point, and when that string will receive the potential energy, string will start vibrating. And along the string, when vibration will take place, the transfer wave will get set up. And therefore, at the plucking point, the transfer wave, suppose I am saying that the crust part of the transfer wave will get set up on the string. So now, this trough part will be incident on this rigid wall. It is a concave part. So it is the trough part is set up along the string, and therefore that trough will be incident on a rigid wall. As soon as trough will incident on a rigid wall, so from the rigid wall there will be a reflection. And already in the second lecture, I have explained how the reflection of transfer wave takes place when it is incident on a denser medium. Now your rigid wall will act as a denser medium. So whenever any trough will be incident on a denser medium, that trough will be reflected as a crust. That trough will be reflected as a crust. And here I am getting the ending of the crust point. At the same time, as your trough will be traveling towards the right hand side, so at the left hand side of the string, the crust will get set up. So now here what the thing will happen? The crust is incident on this rigid wall. And when this crust is incident on a rigid wall, again you have to use the concept of reflection of transfer wave from the denser medium. So now crust is incident on the rigid wall. So that crust will get reflected from the rigid wall with change of phase of 180 degrees. Therefore, your crust will get reflected as a trough. And here I am getting the format of the wave along the length of the string, which is nothing but in the form of loops. And such type of wave is to be called as your stationary wave. So for stationary wave, what are the requirements? Here I have shown that the trough is traveling along the positive x-axis. And whatever this crust will get as a reflected wave, that crust and trough will be traveling along the negative x-axis. Means there will be a setting of, there is a setup of two waves, two progressive waves, which will be traveling along the same axis. Same axis, or in another language I can say that when the two waves are traveling over the same line but in the opposite direction. That is, one wave is traveling along positive x direction, another wave will be traveling along the negative x direction. Along the same line, when they will get superimposed, then due to superimposition, the effect is nothing but the formation of stationary waves. So this is the first requirement, how the stationary wave gets formed. So for the formation of stationary waves, there is a requirement of two progressive waves. These two progressive waves must be there. But what is the condition? That progressive wave should travel in the opposite direction. So that two progressive waves should travel in the opposite direction. Clear? This is the first requirement. What is the second requirement here? Whatever these two progressive waves. Now here what is the happening? Incident wave and reflected wave, they will get superimposed on each other. So for incident wave and reflected wave, both the progressive wave have the same amplitude, they have the same frequency, traveling with same velocity, and they will be traveling along the same line. So they will travel along the same line, means either x-axis or y-axis or z-axis. But the compulsory thing is that the both waves should travel along either x-axis or y-axis or z-axis. And such wave when get superimposed, then there will be a formation of stationary waves. And when these stationary waves will get formed, at that time we are getting a wave which is in the form of loops. So along the string, I am getting the number of loops, and that number of loops form is to be called as your stationary waves. So in this manner, your stationary wave will get produced. Clear? Now the next thing is, we have to derive the expression for the stationary waves whenever it will be formed along a string. For that purpose, I can recall the equation of a progressive wave. So all of you are knowing that in the first lecture of your superposition of waves, for the chapter, first lecture, we have seen the equation of progressive wave, which is equal to y is equal to a sine in bracket omega t minus ax. In that, your a is the amplitude, omega is the angular frequency, and k is nothing but the propagation constant. So where your omega, which is equal to 2 pi upon capital T, your k, which is equal to 2 pi upon lambda. Remember these values very carefully. So this question maybe comes in your MCQ. What will be the value of propagation constant? The propagation constant is nothing but k. K is equal to nothing but 2 pi upon lambda. So if I put now this value of omega and k in the equation, so I am getting y is equal to a sine in bracket, I can say omega value is 2 pi upon capital T into small t minus 2 pi upon lambda into x. So now what I'll do here, inside the bracket 2 pi is a common quantity, so that I'll take common. So what I'll get it here, y is equal to a sine in bracket 2 pi into bracket small t upon capital T minus x upon lambda. So this is nothing but your standard form of progressive wave, which we have already seen. But now here we have to form the two different equations for progressive wave. One is traveling along positive x-axis and one is traveling along negative x-axis. That's why I have written this equation. Okay. Now here I will do slight modification in the equation. What modification I will do in the equation? See here. Here is what small t upon capital T. Instead of small t, I will write it here 1 into capital T into small t. While this 1 by t, capital T is nothing but the period. So 1 by capital T is nothing but the frequency. So what I will write down here? Y is equal to a sine 2 pi into bracket and t minus x upon lambda. And now this equation I am going to use to create the equation of stationary waves. Get it? So now here I can say that in the pattern of your stationary waves, what is the thing here? One wave is traveling along positive x-axis and the another wave is traveling along negative x-axis. So there are two waves. So I can say that let's consider the displacement of first equation. This is our standard equation. Using this standard equation, I can write down the displacement equation for the first wave. So first wave, that's why I write y1. So displacement of first equation y1 is equal to, instead of this capital A as amplitude, I can consider as a small a as amplitude, into sine 2 pi in bracket and t minus x upon lambda. Now in this equation, your small a is nothing but amplitude, m is nothing but the frequency, and the lambda is nothing but the wavelength. Clear? And already we have seen that in the stationary waves, the two waves must have a same amplitude, must have a same frequency. They will be traveling along the same line with same velocity. Clear? So this is your first equation. Now I can write equation for second wave. So second wave, so displacement is y2, which is equal to, again amplitude is same, so I'll write a as it is, sine of 2 pi in bracket, frequency same, so nt factor as it is, minus, now this wave is traveling, first wave is traveling along positive x-axis, means second wave I can say that it is traveling along negative x-axis. So negative x-axis, therefore I can write down here minus. Now this minus x and this minus sign, minus minus will become as a plus. Therefore, now I can write this equation. Just see here, this minus sign and minus sign. So minus of x and middle minus sign. Minus minus sign will get plus. So here the sign will get changed. And here I am getting as a plus x upon. So this is my equation number 1. And here is I am getting equation number 2. Clear? And now, using this equation of displacement of first wave and second wave, now I can use the principle of superposition of waves. So, principle of superposition of waves, according to that, we have seen, according to principle of superposition of waves, the net displacement of the wave is nothing but the vector sum of displacement produced by each wave independently. Now, first wave has amplitude y1, second wave has amplitude y2. So the resultant displacement is nothing but the addition of y1 and y2. Therefore, I can write down here y is equal to nothing but y1 plus y2. This equation I am going to write according to which principle? Principle of superposition of waves. And now I am going to substitute value of y1 and y2. What is y1? Y1 is the displacement of first progressive wave. And what is y2? Displacement of second progressive wave. So now if I put that values, then I can write down here y is equal to, now value of y1. What is value of y1? That is equation number 1. Small a sine of 2 pi into bracket and t minus x upon lambda. This is your equation 1. Plus, second is what? Y2. What is Y2 equation? That is your equation number 2. What I write down that? Here I write down plus a sine 2 pi into bracket and t plus x upon. This is my. So what I have done just I have kept the values of y1 and y2. Clear? Now in this addition format, this a factor is common. As this a factor is common, so now what I can write that equation? Here I can write the equation that I will take y factor as a common factor. Sorry, a factor as a common factor, and I will write down y is equal to, here I will write a in bracket sine of 2 pi in bracket and t minus x upon lambda plus sine of 2 pi into bracket and t plus x upon lambda. Complete. Got it? Now, what is the next thing? See the first term. In the first term, along with sine, which term is there? 2 pi and t minus x upon lambda. Instead of that, I will assume this factor as a c. And for second in bracket nt plus x upon lambda. For this term, I will assume d. Clear? Means, in short, what I will write down here? Y is equal to a in bracket sin c plus sin d. Get it? Now it is sin c plus sin d. So now you have to solve a trigonometric equation. In mathematics, you have seen this identity. Sin of c plus sin of d. That can be written as y is equal to a in bracket. If you are remembering that identity, sin c plus sin d can be written as 2 sin of c plus d upon 2 into cos of c minus d upon 2. This is your trigonometric identity. And now you are using that trigonometric identity here. Because already we are knowing what is value of c and what is value of d. So just I use that value of c and d, I can substitute and I can solve that equation. So what I write down here now? Y. Clear? This 2a factor I come, I will take 2 factor outside. So 2a in bracket. Now what is that? Sin c plus d upon 2. What is c? C is here. 2 pi and t minus x upon lambda. This is c. In that, what we are going to add? D. What is d factor? Plus 2 pi into bracket and t plus x upon lambda. Now in the first c term, there is a term minus x upon lambda. And in the d term, there is plus x upon lambda. So when you will add that c plus d, so plus term minus term will get cancelled. So what is remaining? 2 pi and t. Here 2 pi and t. So nt, 2 pi factor is common. Nt plus nt will be 2 nt, and that 2 nt will be divided by again 2. Means what I am getting here? 2 sine of 2 pi nt. Why? Because whatever here addition I am getting 2 nt upon 2. So that 2 factor will get cancelled. And here I am getting that along with sine term. Here I am getting nt. Into next term into cos of. What is the thing? C. C is what? 2 pi and t minus x upon lambda minus 2 pi and t plus x upon lambda. So middle sign is minus. So that minus sign get multiplied inside. So your this nt term will become minus and plus x upon lambda will become minus. So plus nt minus nt term will get cancelled. And what I am getting here, it is 2 pi in bracket. Here I am getting as a, here nothing but minus x upon lambda minus x upon lambda, that is 2x upon lambda whole divided by 2. Means here I am getting here as a minus x upon lambda. 2 factor will get cancelled. So what I am getting here, 2a. And again here factor, sorry, here 2 I will not write because already I have taken 2 common. So 2a in bracket sine of 2 pi nt. Here cos 2 pi minus x upon lambda. Means cos angle is negative. And we are knowing that cos of minus theta can be written as a cos theta. So now I can write the equation. Your y is equal to 2a in bracket sine of 2 pi nt into cos of 2 pi x upon lambda. Right? And now I am going to concentrate on term 2a and this cos term. So 2a into cos of 2 pi x upon lambda. Instead of that, now I am going to write down capital A. So I'll write equation y is equal to capital A into sine of 2 pi nt. What is capital A? Capital A value, here I can say that I will write down the capital A value is nothing but the resultant amplitude of the stationary wave. Because now this is I am getting as an equation of stationary wave. So your equation of stationary wave y is equal to capital A sine of 2 pi n. A is the resultant amplitude. Sine term consists of frequency and time. But sine is not varying with x. Means your displacement equation is independent of the distance. Means your stationary wave, when gets set up, it is independent of the displacement. Means stationary wave is not moving along a string. The stationary wave remains as it is along the string. It will remain at the rest position along the string. And that's why this wave is to be called as a standing wave, or it is called as a stationary wave. Stationary means what? The wave particles are not moving and the equation doesn't consist of x term. Displacement term nahi hai. Displacement term nahi hai means what? The particles are not in the motion. Particles are not in the motion means what? Particle will remain at the rest position. And when particle will remain at the rest position, it is to be called as your stationary wave. So here I am getting why it is called stationary or why it is called standing wave, and here I am getting the equation of stationary wave, right? And from this stationary wave, I can write down here the equation of resultant amplitude, capital A. Just concentrate on these two equations. What I write capital A? Capital A is equal to nothing but twice small a into this cos term. So I'll write down it is equal to 2a cos of 2 pi x upon lambda. This is nothing but your equation for resultant amplitude of the stationary waves. Clear? Now concentrate on this diagram of your stationary wave. In this diagram of stationary wave, if you are concentrated, that is at the rigid wall, these two waves are meeting together. The point is stationary. At the plucking point also, the point is stationary. Point is on the string. Point is at the rest. So these 3 points, I can call it as this A, C and B point. All these 3 points are to be called as a node point. Node point means the particle of the medium will remain at the rest position. Rest position means what? The displacement is 0. Displacement is 0 means what? Amplitude of that particle is 0. Particle is not set into vibration. So at this point, A, C and B are nothing but your node points. While in between A to C, see here, your particles are set into vibration in up and down motion. So from A to C, there is a change in amplitude. From A to middle point, I can call this point as a D point. So at the D point, amplitude is maximum. Here also, in second loop, at this E point, your amplitude is maximum. So when your amplitude of vibration is maximum, is at that time I am getting the amplitude. So what I say that at this P and E point, here I am getting the displacement maximum, and that points are to be called as your antinode point. While A, C and B, the medium particles are not in the state of vibration, they will remain at the rest position. So these 3 points, A, C and B points, are to be called as a node. So in short, what is our conclusion? At node point, amplitude of the particle, amplitude of vibration of the particle is 0, and at the antinode point, amplitude of vibration of an particle is maximum. So by considering that case, I can find out at what displacement you will get the node point and at what displacement I will get the antinode. So now I can write down for node point. For node point, what is the thing? Amplitude is equal to 0. And what I have a resultant equation? I have a resultant equation. Amplitude A is equal to 2A cos of 2 pi x upon lambda. So this amplitude is 0. So what I say that instead of A I put 0. 0 is equal to 2A cos of 2 pi x upon lambda. This I'll write down as the amplitude equation. Now what is the thing? There are two terms. One term is 2A, second term is cos term. 2A, A is nothing but the amplitude of your individual wave. So that individual amplitude is never to be 0. And these two terms are in product. And their product is 0. So product is 0 meaning is what? Either first term is 0 or second term is 0 or both the terms are 0. But there is no possibility that first term is never to be 0. So automatically the term remains to be 0 as a second term. Means what I say here, your cos term, cos of 2 pi x upon lambda must be equal to, and to get this cos theta is equal to 0, the theta value has a restriction. That is, your mind that cos 90 is 0, cos 270 is 0. Cos 90 is 0 means what? Cos of pi by 2 is 0. Cos of 3 pi by 2 is also equal to 0. Means your theta value is either pi by 2 or 3 pi by 2 or 5 pi by 2. At that point, your cos angle will become 0. Means what you can say here, your theta value, which is nothing but 2 pi x upon lambda, is either pi by 2, so their cos angle will be 0, or it is 3 pi by 2, your cos angle will again become 0, or 5 pi by 2, again your cos angle will be 0. So like that manner, for particular angle value, cos will be 0. So that angle value I can write down. And once I have written that value, then from that I can find out the location of your node point. So now here I can note down, there I will get the location of a node point where displacement is 0. So for that I will use first condition. What is the first value? Theta value 2 pi x upon lambda is equal to pi by 2. At that time your cos angle is 0. Cos angle is 0 means I can say that therefore here value of x I am getting. See here from both sides this pi factor will get cancelled. So what is remaining? X is nothing but your lambda by 4. Clear? Okay, second value. Second value is what? 3 pi by 2. Means this angle value 2 pi x upon lambda must be equal to 3 pi upon 2. Again this pi value will get cancelled. And then I am getting this x is equal to nothing but 3 lambda by 2. Similarly, for next I can use 5 pi by 2. So your angle value 2 pi x upon lambda is equal to 5 pi by 2. Again from both the side pi factor will get cancelled. And then I am getting value of x is equal to nothing but 5 lambda by 2. Clear? So in that manner, here I am getting the location of node point. So in generalized format, what I say? 2p minus 1 into lambda by 4 is nothing but the distance where I will get the node point. Where your p value is nothing but your integer value, I can say. So if I am saying that, if I put your p value from 1 to n, so I will get the location of node point. See here, if I put first value, p is equal to 1, first node where I will get, so p is equal to 1, I will put here p is equal to 1. So 2 into 1 is 2, 2 minus 1 is 1, 1 multiplied by pi by 4. Means I am getting first node at the displacement lambda by. Similarly, I can find out for second node, where I will get the second node. Second node means now I will change the p value as a 2. So p value 2. So 2 into 2, 4. 4 minus 1, 3. And 3 is multiplied by lambda by 4. Means I will get second node point at 3 lambda by. Got it? So for MCQ, this part is important. At what distance we can get the node. So the distance where I will get the node, that distance, generalized distance is nothing but x is equal to nothing but 2p minus 1 lambda by 2. And your p number is nothing but the integer number. Clear? Now, here I can find out one more thing. At a distance of lambda by 4, I am getting first node. And at a distance of 3 lambda by 4, I am getting the second. So now distance between two consecutive nodes. So distance between two consecutive nodes, that I will write down here as a distance between two successive, or I can say consecutive nodes, can be written as first node I am getting at lambda by 2. Second node I am getting at 3 lambda by 4. Means what I write down here? 3 lambda by 4 minus lambda by 4, which will be nothing but 2 lambda by 4, which is equal to nothing but lambda by 2. So this is also one of the important statement for your MCQ. That is, distance between two successive nodes is nothing but as your lambda by 2. So that thing you have to remember very, very carefully. So this is for the, so for node, which point, important point you have to note down? Point number 1. For the node, amplitude is 0. Second, the location of node points are at a corresponding distances lambda by 4, 3 lambda by 4, 5 lambda by 4, or generalized formula I can say as a 2p minus 1 into lambda by 4. And number 3, that is the distance between two successive nodes is nothing but as your lambda by 2. Getting? Now similarly, I can find out for anti-node point. So now I will say for anti-node point. So here I will write for anti-node point. Now already in the diagram we have seen anti-node. For anti-node, what the thing? Amplitude is maximum. So for anti-node, amplitude is maximum. Now here maximum value of anti-node is what? Plus minus 2a. Why I have written here plus minus 2a? What is your resultant amplitude? Your resultant amplitude A is equal to 2a cos of this angle. Cos theta has the maximum value plus 1. Right? And in the negative sense, the value is minus 1. So cos angle has a maximum value plus 1 minus 1. So that plus 1 minus 1 is multiplied by 2a. And therefore, you will get it. Your resultant amplitude A is equal to plus minus 2. To get that amplitude plus minus 2a, here I will say that now your A value is plus minus 2a. That value I will write down. From both the sides, this 2a to a factor will get cancelled. Means what I will get the condition? Your cos angle is what? Cos of 2 pi x upon lambda must be equal to plus minus. So when your cos value, cos theta, cos 2 pi x upon lambda is equal to plus minus 1. For that theta, I am getting amplitude is maximum, and then that corresponding point is to be called as your antinode. Clear? Therefore, I can derive their conditions. As a cos of 2 pi x upon lambda is equal to plus minus 1. In that case, now I can put the theta value. So what will be your theta values here? So your theta value 2 pi x upon lambda. This angle value either 0. Because you are knowing that cos of 0 is plus 1 and cos of pi is minus 1. Means for pi value, this angle value will become minus 1. So cos 0 plus 1, cos pi minus 1, again cos 2 pi plus 1, cos of 3 pi minus 1. So like that manner I can write the values of this. Getting? And now here Now I can find out the locations where I will get your antinode point. So here I can say that for location of antinode point, now I can write down here. Suppose I am saying that location of antinode point, your angle 2 pi x upon lambda is equal to 0, first one. So what is x value? Here x will be nothing but 0. Because lambda is a wavelength of progressive wave, which is never to be 0. So 2 pi x upon lambda is equal to 0 means your value of x must be equal to. When your next value is nothing but your pi value. Means what is the thing? 2 pi x upon lambda is equal to lambda. So your pi value will get cancelled. So what I am getting, value of x is nothing but lambda by 2. Next angle value, if I am saying it is 2 pi. So from both the sides, this 2 pi will get cancelled. What is remaining? X upon lambda is equal to 1. Means your x is equal to. So like that manner, I can get the distance where I am getting the antinode. So I will get first antinode when displacement is 0. I will get the second antinode when the displacement is lambda by 2. I will get the third antinode when the distance is lambda. So in generalized formula, I can write down P lambda by 2. Where P value will start from 1 to n. And at that particular distance, I will get the locations of antinode. Clear? Any doubt? So now again I can draw a certain conclusion. What is the conclusion? Now I can find out the first antinode I am getting at 0. Second antinode I am getting at distance of lambda by 2. Means distance between two successive antinodes is what? Lambda by 2 minus 0, which is equal to lambda by 2, which is same as that of node distance. Getting? So in case of node also, in case of antinode also, I can revise 3 important points. For antinode point, amplitude is always maximum. And what is the maximum value of the amplitude along the stationary wave? That is plus minus 2. To get that amplitude maximum, your theta value will be 0, pi, 2 pi and so on. And therefore, I am getting location of antinode points. X is equal to 0, lambda by 2, then lambda, or in generalized format, I can say it is P lambda by 2. Now, P value will start from 1. Means your first antinode. Means what I can say that here, first antinode, P is equal to 1, so lambda by 2. Second antinode, again P is 2, so 2 factor will get cancelled. So I am getting clear, and like that manner I can find out the value of antinodes, distance of antinodes where I will get it. And from that I can draw the conclusion, that is distance between two consecutive antinodes are nothing but lambda by 2. Clear? So now from this expression I can draw one more conclusion, and that is nothing but, see here, I am getting first node at a distance of lambda by 4, and I am getting first antinode at a distance 0. Means what I can say that now, distance between node and successive antinode which is nothing but node I am getting at lambda by 4, first node, first antinode I am getting at 0, so lambda by 4 minus 0. So distance between node and successive antinode is nothing but your lambda by 4. Clear? So now you have to remember these important points, that is distance between two successive nodes is nothing but lambda by 2. Similarly, I can say that distance between two successive antinodes. Distance between two successive antinodes that I can solve as a lambda by 2 minus 0, which is equal to lambda by. Clear? So this is nothing but about your stationary wave equation, formation of nodes, formation of antinodes. So I'll recall 5 points for the node. Node means the displacement of the particle is 0. Now, here I'll give one more important point. For node point, displacement is 0, but the pressure exerted is maximum. Therefore, each node, displacement node, is to be called as a pressure antinode. Because जहाँ node पे displacement 0 है, वहाँ पे pressure maximum. So that's why it is to be called as a pressure. So first point of the node, displacement is 0, but pressure is maximum. Second, the node point will obtain at a distance lambda by 4, 3 lambda by 4, 5 lambda by 4, or general formula 2p minus 1 outside the bracket lambda by 4. Then, third important point, distance between two successive nodes is always lambda by 2. Clear? Fourth important thing, all nodes are situated at equidistance. So just say, in between any two nodes, always distance is lambda by 2. Means what we can say that the nodes are situated at equidistance points, or we can say that nodes are equally spaced. And same thing I can call for antinode. Antinode means the displacement at that particle, amplitude at that particle is maximum. So amplitude is maximum, means pressure exerted is minimum. Therefore, it is to be called as a pressure node. I will again recall that at antinode, displacement or amplitude is maximum. So at that point, pressure created is minimum. So which is to be called as a pressure node point. That is point number 1. Second point, at antinode, amplitude is maximum. And the distances where I will get the antinode is nothing but 0, lambda by 2, lambda. General formula is p lambda by 2. Fourth important thing is distance between two consecutive antinodes is lambda by 2. And therefore I can say that distance between two consecutive nodes is equal to distance between two consecutive antinodes. And the last important point, if I check distance between any two successive antinodes, every time it is getting lambda by 2. Means along the stationary wave pattern, antinodes are equally spaced. Antinodes are situated at equidistance points. So this is about your stationary wave, node and antinode. So your node and antinode part is important for very short answer, for MCQ as well as for mini. So that 3 important statements you have to remember. Distance between two successive nodes, lambda by 2. Distance between two successive antinodes is lambda by 2. Third point, distance between node and successive antinode is lambda by 2. Clear? And now, in this diagram, here I am getting 2 loops. So this loop length, first loop has node at A point, node at C point, and antinode will be at the center. So if I am considering one loop, so for one loop, end points are node, center point is antinode. And the length of the loop is equivalent to distance between two nodes. So in the problem, if length of the loop is given, means it is given the distance between two successive nodes. So length of the loop is equivalent to lambda by 2. Clear? So here I am going to stop my today's lecture. So this much information is enough for